All right, we have in the reaction 28 grams of water produces 79.59% yield of hydrofluoric acid. So this is our known 28 grams, and it's going to give us a yield of hydrofluoric acid or hydrogen fluoride, depending on what its state symbol is, which means we're going to have to use the stoich to find the theoretical yield. Because remember, theoretical yield is what the stoich says. And if we have the percent yield and the theoretical yield, we can find how many grams are produced, which would be the actual yield. Slide that over a little bit there. All right, they already gave us a balanced chemical equation. Just remember that if they don't show any coefficients, your coefficients are 1, you need that for the mole ratio. And in this case, our mole ratio is going to be easy because it's 1 to 1. Start with what you know, 28 grams of water. Okay, always go to moles. Grams to moles is dividing by the molar mass. Now we have to convert from moles of water to moles of hydrofluoric acid. We know what we want to find is always in the numerator. What we want to get rid of is always in the denominator so that it cancels. So even though this is a 1 to 1, you still write it out, because that way it also helps make sure that when you get here that you're multiplying by the molar mass. And there's 20 grams in 1 mole of hydrofluoric acid. Plug that into a calculator. I get 31 grams of hydrofluoric acid. So that's the theoretical yield. That's what the stoich says. Okay, we're trying to find the actual yield, so we're going to use that equation. Percent yield is equal to actual over theoretical, part over whole. Actual is always smaller. We always lose some when we're doing the lab. And we'll substitute in 79.59% equals actual over 31 grams times 100%. Convert these back to a decimal, 0.7959. 100% becomes 1, so we don't even have to worry about that. 0.7959 equals A over 31 grams. Multiply both sides by 31 grams, and you get your actual yield of 25 grams HF.